Again, we have our familiar word, uniform meter scale. Okay, so this is a uniform meter scale. So this is 0, this is 100, and the knife edge is placed at 58. So we have 58 over here. We know that the weight will act at the center. Okay, so 20 gram force is suspended at one end. Again, we have done this before. The shorter end is this. So 20 gram force has to be placed over there. This is the weight of the scale W. So we write the statement that sum of clockwise and sum of anti-clockwise are equal because the scale is balanced. So W multiplied by this distance from 50 to 58, so that is 8, is equal to 20. Now this distance from 58 all the way to 100, so that will be 42. So this will be 20 into 42 upon 8. 4 2s are, 4 5s are, 2 1s are, this is 21. So that will be 105 gram force. Okay, so the weight of the ruler is 105 grams. Okay, let's go to the next question. Calculate the least force required to balance 200 gram of uniform meter scale pivoted at 35 centimeters. Okay, so again a similar question. So this is a uniform meter scale, 0, this is 100, and it is 200 grams, so therefore 50. This will be 200 gram, and I call it as gram force, and it is pivoted at 35, and you want the least force, so therefore it has to be at the farthest distance. But because this is the shorter end, we have to apply the force over here. Fine. So again, since the scale is balanced, sum of clockwise moment and sum of anti-clockwise moment are equal. So W into 35 is equal to 200 into 15. So this separation is 15. So this is 200 into 15 upon 35. So 5 3s are, 5 7s are. So this is 600 upon 7. You cannot leave your answer in fractions. You have to write it up correct up to 2 decimal places. The answer will be 28.57 gram force. That will be the weight of the scale. That will be the least weight that has to be applied at one end to balance the scale. Question number 12. A uniform half meter rule balanced horizontally at the knife edge at 29 centimeter mark. So this is a uniform scale. Again, that means the weight act at its geometric center. But this is a half meter rule. Half meter rule means, so this is a half meter rule. So this is 50 centimeter long. This is 0. This is 50 centimeter. So 25 centimeter will the weight act. And the knife edge is placed at 29. So this is 29 where the knife edge is placed. And a weight of 20 gram force is suspended at one end. Again, the same logic. This is the shorter end. This is the longer end. So the weight that is kept to balance should be at the shorter end. That is over here. And that is 20 gram force. Draw the diagram. We have done that. And what is the weight of the half meter scale? Again, the same statement that if the scale is balanced, sum of clockwise moment is equal to sum of anti-clockwise moment. So we have W multiplied by this distance, 25 to 29, that will be 4. And this will be 20 multiplied by this distance. So that will be 29 to 50. So that will be 21. So this is 20 into 21 upon 4. This is 5s. So this is 105 gram force. That will be the weight of the half meter scale, that is 105 gram force. Let's move to the next question. The theme, it's a meter scale, is kept in equilibrium when supported at 60 centimeter mark and a mass of M is suspended at 90. Okay, that is shown in the diagram. State with reason whether the weight of the scale is greater than, less than, or equal to M. Okay, so the weight will act over here. So if we say that it is an equilibrium, which is given to us, so this distance, which is 10, is equal to M, and this distance is 30. So this is 3s. So W is equal to 3 times M. So therefore, obviously W is greater than M. Okay. So with reason whether the weight of the scale, it is greater than, less than, or equal to. So it is greater than M. Okay. Let's move to the next question. Question number 14. This is again a half meter scale because this is 0, this is 50. And it is suspended by a thread at the midpoint. So that is at 25. Okay. It is balanced horizontally when 50 gram and an unknown weight W is suspended from 10 centimeter and 45 centimeter. Calculate the weight. So it is balanced. So again, the same thing. You have 50 multiplied by this distance, that will be 15, is equal to W multiplied by this distance. So that will be 20. So W is 50 into 15 upon 20. So this is equal to 75 upon 2, that is 37.5 gram force. Okay, remember the weight will be, the unit will be of the other weight. So this is 50 gram force. So the other weight will be 37.5 gram force. Let's move to the last question. Question number 15. This is a meter scale which is in equilibrium as shown. Calculate the weight of the scale. So this is a uniform meter scale. So the weight will act at 50. And this is W. So 40 multiplied by this distance. Okay, don't forget to write the statement. So this is 40 into 25. This will be 20. So this goes 2 times. So W is equal to 50 gram. So answer to the first question, the weight of the scale is 50 gram force. Now the second part, which of the following options are correct to keep the scale in equilibrium when 40 gram force is shifted to 0 centimeter? Okay, let me clear this and I'll keep this part. So this is 50 centimeters. And this we have got as 50 gram force as well, okay, from this calculation. So this question says that 40 gram force is shifted to 0. So over here, this is 40 gram force. Now with the situation as it is, will it be balanced? The answer is no. Why? Because now the distance is not 25, but it is 30. So therefore 40 into 30 will give you 1200 gram force. Whereas this distance is 50 multiplied by 20, that will give you 1000 gram. So it's not going to get balanced. How can you balance it? You need to reduce this distance so that this distance increases. That means the fulcrum has to shift here. So that means it has to shift towards 0 centimeter mark. Okay, so the fulcrum has to shift over there. The other one was shifting it to 100, near 100, or towards this side, the right side. That is not an option because that will make this more than 30 and that will make this less than 20. So this will be further increasing. We don't want that. We want it to be balanced. So therefore the knife edge has to be shifted towards 0. That's the answer. So this video we have solved few sums and these covers all the time. I hope you have understood. Thank you.